All right, we are going to talk about collections. Sorry, just set this up. So, as you know from the notes, there's a couple of important interfaces. The collection, which represents things that hold individual items, and maps. And a map is like a dictionary. In fact, other languages call it a dictionary. For example, Swift or Python. It's rare you would actually declare a variable to be a collection, because you generally care if it's a list or a set. There's a couple of different properties. A set doesn't allow for duplicates. A list does. A set is unordered. It doesn't remember, typically, doesn't remember what order things are added to it, whereas a list does. So we could say something like this. New linked list. And then I could say collection add hello. Evil world. I like soup. And then we can just do this here. Let's see the traditional. So you're used to doing something like this. I'm going to show you what not to do. Please never ever actually do this. Actually, I can't even do it with this one. I'll have to wait until a little bit later when I have it as a list. So this is what we'd normally do. So that's what we would normally write. That's very similar to writing the more verbose version with an iterator. So this is the equivalent. A long time ago, we didn't even have this. We had what's called an enumeration. And it worked slightly different, but it wasn't didn't use generics. So we have an iterator. We can go through it one, until we reach the end and get it out of it one at a time, or we could just use this shortcut here. And this is highlighted because it's going to tell me something about. I can replace this with an enhanced for loop. See, basically the same thing. And this one, I'm not going to do it, but this one tells us that we could replace it with, oh no, actually it's just saying that it's empty. So this IDE doesn't automatically give me the option to replace this with a different way of doing it. I'm going to show you that in a different video when we get to Lambda. So if I run this, it should print out, hello, evil world, I like soup. And there we go. And because I've declared it as a collection, I can make it any kind of collection. So I could make this an array list. Nope, didn't have the import. and it'll behave the same way. All things being equal, ArrayList is probably faster than a linked list. We'll talk about the implementation of it at a later video. But an array list behind the scenes is just an array. So you can't use the square brackets to access things, but other than that, it's almost the speed of an array, whereas a linked list is a much more involved thing. So it depends on what you're doing. If you're putting things in at the end, an array list is fast. If you're putting them in the middle, it's much slower. In terms of, when would you notice it? It probably takes like a list with like a million things of it for you to start noticing an appreciable slowdown. But generally speaking, you're going to want to use an array list. And again, because it's a collection, I can do it as a hash set. And that is going to give us these in a random order. It should be consistent though, so it's soup like hello evil eye world. Soup like hello evil eye world. If I add these in a different order though, that's going to totally change where it is. Notice the eye didn't appear at the beginning, and there's no rhyme or reason to where it's appearing, right? So I think that was a different order. Let me just double check. No, turns out to be the same. Don't know why. Oh, I did a hash set. No, I did a hash set. Yeah, the other one's a tree set. I'm actually doing things I've never cared about before. I honestly don't care what the order is. That's the whole point of a set, is I don't know or care what the order is going to be. A tree set, though, is going to sort them alphabetically. And that's the property difference, right? So a tree set, everything's alphabetical. Or ordered. If I change it to numbers, it would be from 0 to 100 sort of thing. Strings will be ordered alphabetically. And it uses what's called the natural order, and we'll cover that later on in here, but keep that thing in mind. So that's if I declare it as a collection. It's rare you would declare something as a collection. Much more likely you declare it to be a list or a set. Right? So the set properties, no duplicates, and the order not guaranteed, unless you use a tree set. And if you really care that it's sorted, you can declare it to be a sorted set. There's not much advantage of doing that, so I generally don't do that. Kind of a hint to the person saying it is like, I guarantee this will be sorted. I don't think I've ever cared. But if we do it as a list, and we make it a linked list, right? So this will still come out hello evil world. I like soup, no difference. And I was saying this is the way you should do it, with the lambda stuff, which we'll get to. But the way that I do not ever want to see anyone do this is this. When we look at the implementation for a linked list, you'll understand why that would be an absolutely horrible way to do things. This is super slow, okay? You do not want to do this. If you're doing this, you're doing something horribly, horribly wrong. So never do this. If you want to, sometimes you do want to know what the index is. So there's two ways you go about doing that. We could make a variable like this and go back to what we had before. And then do I++ here. So if you really want to know the index, you can do that. That's one way. I don't recommend that. There's another way. Turns out that this is not something you do very often. The times I have actually done this compared to the other one is like 0.25%. It's ridiculously small. Oh, actually, I might be misremembering. I thought that, oh, no, I think it's a list iterator. So I never do this. I used to have to do next index. So let's see what this prints out. I'm not sure if this will start at 0 or 1. So it starts at 1. So your current index is the next index minus 1. Unless there's an actual index method. Nope. So that's a, if you really want to do that, there you've got that next index method. I don't know the API. I intellectually knew it was there, but I don't think I've ever used it. I think I've just done the int I as an I++ thing because it's just kind of a pain to use. I'd rather use the short form, but this would actually be the better way to do it. So that is collections, the collection interface for now. I'm going to comment this out. But that's about it. For 90% of what you want to do, you just want to add to it and you want to go over it. You might want to remove something. So there's a collection.remove method and things like that. But they're pretty straightforward. You add to them, you move them, you can iterate over them. 99% of your time is going to be spent doing that. Maps, on the other hand. So you'll notice this is, as I've said, it's a dictionary. So here it's a key and the value. So the string is a key, or the key is a string, and the value is an integer. And just like we had hash map or hash set, we have hash map, which is some randomly ordered kind of thing. It's based on the hash code, and the other one is the tree set, which is sorted by the alphabetically or whatever natural order by the key. And you don't add to it; you put. So Darcy's number 1, Jason's number 2, Pat's number 3, and we can print out the map and just see what it does. It'd be interesting, possibly. So Pat has 3, Darcy has 1, Jason has 2. Don't normally print out maps, but you can see what's in there. More likely you can do something like this. You're going to get the value. And actually, if we want to be consistent, one thing you'll notice, I declared it to be an integer, and I'm assigning it to an int. That's that happy auto boxing and unboxing thing. But we'll see what happens in a second if I do this wrong. So I got 1. If I put in Pat, I'm going to get 3, presumably. So this is a really handy way to look something up, right? Instead of doing a big switch statement or huge if-else's, we can use the string. If, however, I put something that doesn't exist, Pat X, we get a crash, a null pointer exception. This one gets weird. So we get a null pointer exception on this. So map is null, right? Because it's always the thing before the dot. No, that's not the way this works. When it unboxes, it basically says, I got it as an integer. See, if I just declare this as an integer, it'll work. It'll print out null because it wasn't there. but that's not what happens. Essentially, it gets that, the auto unboxing gets that value as an integer and then calls dot int value, which is going to crash because this is null. So that's exactly the problem we saw. It's just hidden. It's not obvious as to why it's happening. And I've had this happen to me, and I've wasted like 20 minutes on it trying to sort out what was going on. There's a way around this. A couple of ways around this. Am I wrong? Getter default. Right, so if it's not there, we're going to get the value of 100. So pat x will return 100, whereas pat will return 3. Okay, so we can handle it that way. Another way you could do it, depending on how your system's working, is you can say if the map contains key pat, right, and if I put in pat x here, it won't print anything out because it didn't find pat x. Right, so we can test for it that way. In practice, I almost never use either of these methods. I'll use a contains key on occasion, but not to see if something's there. I actually use it for other reasons. Sorry, not to see if something's there so it won't crash. Generally speaking, it's I want to make sure that something's not there, and if it's not there, I'll add it. And I'll actually give you an example of that shortly. I think I intellectually know getter default is a thing, but I've never actually used it. And I rarely make lists or maps of integers, so I rarely have this actual issue crop up. But it does happen. We could change this to be integer and string, and the generics will help us out here, saying, wait, you said you're putting in a string and an integer, but I'm supposed to take an integer and a string. So that's where the generics come in handy. So let's look at a more realistic example with the map. Actually, gonna get rid of everything. Actually, let's no, this will be fine. No, let's go with the okay, let's go with the complete example. So let's say we're making a calculator. And the calculator has operations like plus, minus, times, divide. We'll limit ourselves to integers. Sorry, I'm going to stop the video and try and splice it together after. Some noises going on in my house. Hopefully this splices back together fine. So we are making an addition operation that implements the operation. So this one can add, and we'll do another one for subtraction. That'd be just a minus b. So we're going to put in here, and I'm going to show you two ways of doing this. So we're making a map of strings and operations. And actually I'll go even further, and I'll do it the way I would normally do it. So strictly speaking, this is a constant because it's only going to receive, it's got one value, and it's for all of the instances of the class. And I'm going to put the plus symbol and a new addition operation. And I'm going to put the minus symbol with a new subtraction operation. And I'm going to rename that because it got it wrong. Cool. Okay, so we've now got our operations. We've got plus and minus, and I can do this. Helps if you spell properly. So this should equal 3, hopefully. It equaled 3. And if I put in minus, it should equal minus 1, because 1 minus 2 is minus 1. Now we could pass this in through the command line. And if you don't remember how that is, we'll just do this and go into the configuration and put in plus. And let's actually, we'll just do that plus. And we'll run it. And now we get 3. If I come back here, edit configuration, put in minus, and run it, I get minus 1. So now I can make it so my program doesn't know what it's doing again, right? It's going to do some sort of operator, plus or minus. If they put in an asterisk, obviously that's going to be a problem, or a division, or square root, doesn't matter, because I don't support that. So that's where I'd have to check to see, does the operation actually exist, right? So here I can say if operation is not equal to null, do that, otherwise, do whatever. So there's a few ways you can go by doing this, right? This isn't dealing with the auto boxing and unboxing thing, so it's fine to do that, which is normally what I do. And so that's one way. The other way, if you want to make things really dynamic, and I wouldn't do it for this particular case, but since I've got this structured this way, we can do it. I'm going to put in the addition operation dot class. That means this is going to hold a class of type operation, but it's not operation, it's question mark extends, right? So it's got to be some kind of operation. Let's copy that. And now I'm going to make my own method. We call this operator. to call this op, because I'm going to call this operator class. And so this is, I'm going to show you that thing, which I'm deciding I might like actually. Operator class is assigned operations.get and the op. So this is actually a little verbose, and if I were to actually break my rule, I keep breaking my rules though, but if I break my rule, I think I can substitute this with var, and it's all good. That's pretty attractive, because notice it got rid of that big ugly thing, right? And the var just lets the compiler infer, right? It knows that operations is a map that holds classes of things that extend operation. So it knows that this var is a thing that holds operations. Kind of liking that. I may have to rethink my life. So then if the operator class equals null, throw new. I wouldn't actually throw in a legal argument exception. I just don't want to go through the trouble of it right now. I'd make a new invalid operation class. Right, so I'd make my own checked exception. I'd add the throws there and all that to make it so that people didn't ignore it. But for speed, I'll do this. And then I can say new instance. Oh, it doesn't want me doing new instance anymore. Apparently that's been replaced. Which makes me sad. I'm not going to worry about that right now. I am going to go look up the right way to do it though. And I will update it at some point in time. Remember, you get the constructor and all that kind of stuff too. I wonder if I do this. I wonder if this will work. It will. And now I'm not going to do this anymore. What I'm going to do is call, this should be a static method, so I'm calling it from main. And it's going to make me catch the or deal with the exceptions. So illegal access tells us that the constructor may not be public, class may not be public. Instantiation exception, just, we are having trouble instantiating it. This is the thing I told you never to do. It's a test program. We can do it in a test program, right? Never throw have main throw an exception in a real program. But this is just a throwaway program to test something out. So here we go. And it does -1, and if we change it, it will do plus. Right. This is a bad example because I have no particular reason. It's just like that I return it. I'd like to make temporary variables though. So this is a bad example because every addition operation does the exact same thing. There's no state, right? To have state, you need instance variables. Eye color, hair color, your name, your social insurance number, your birth date. Those are all state. We don't all share the same birth date. So since there's no state, there's no need to create a new one each time. But if you did need to create a new one each time, this is the kind of thing you could go about doing. I will redo this particular thing, so I'm curious. I know there's a new API for it, and I just don't remember what it is. I've never used it. It's new to me, and I need to go do some investigation on it. Apparently it's faster, So I will investigate why this is deprecated and all that, and get back to you. But that's the basics of things. I'm going to change this to be a tree map. There's one more thing I wanted to show you, and I'm going to just, in the case of here, I'm going to do system.println the operations, and when we run this, it's decided that this is a sort order, right? Plus, then minus. If I want to sort that the other way around, I don't like that. I have a few ways I can deal with that. First off, for this to truly work properly, I really should say that this extends comparable operation. I think it's actually technically question mark extends operation. Nope, just operation. And now it's going to be unhappy here because we're not providing the method that it requires, which is compare to. So I'm going to compare, I need a new method now. Returning 0 means that they're the same. Here's an example where it's like, okay, I want to change this to be a, oh, actually, I'm not going to bother. I'm going to be really cheap, but you're going to see why we use inheritance. I'm going to need to have a method. String get symbol. So this one returns, oops, plus. And this one returns minus. So what's wrong with this is that I've got the get symbol returning just plus or minus. I'd really like to make that a variable up here. But I can't make this a variable up here because it's an interface. I need to make this an abstract class. Or I need to introduce an abstract class. It would probably be better. And it can't change, so we'll mark it as final. Once we mark it as final, it's going to flip out because we haven't given it a value in the constructor. Abstract classes, give them a protected constructor, because protected means it's accessible by the class and its subclasses. Well, that's what we want. Plus classes in the same package. I should also check to make sure that if the sim equals null, that the sim cannot be null, right? Remember, check all your parameters. Don't have to check these ones because, it's an int. Every int is a valid integer. Unless I wanted to only limit it to positive numbers, for example. It's 7 o'clock. There's noise outside. Now I can get rid of get symbol here, and I can get rid of get symbol here. And I can put it in here. And this doesn't work because I'm not extending abstract operation. So this is going to implement operation. This is going to extends abstract operation. So now it doesn't need to have the get symbol method anymore. All this work, so I only have to have this get symbol in one place. Now it's unhappy because we haven't called the constructor. And I don't want to give it an argument. I want to just go super plus. So have I actually saved myself any work? Not really. And that's okay. It looks like I actually created more work for myself, doesn't it? But the principle is the same. Now everything's got symbol up at the in one place, right? So I haven't duplicated this variable or hard-coded that it's just a plus inside of my method. I can now call get symbol on every class, which I could do anyways just by making that abstract. It's just moving common things up. I don't want to have this method duplicated in multiple places. So now we can move this up to the parent class, and all of these ones can inherit it. So let's see if this runs. It does. So we've got our plus and our minus. Back to what we were saying before. Let's say I don't want, I haven't done the compare to. So what I can just do is return super dot get symbol dot compare to the other operation dot get symbol. So I'm just going to compare the two symbols, and oh, that method's going to be the same for both too. Well, now I'm actually getting some benefit from my abstract class. And I don't need get symbol anymore. I can just refer to symbol. This is something that confuses students here. This is a private variable. I'm going to access it directly, even though it's on another class. Sorry. Oh, have they changed that? Oh, it's not an abstract operation. If it was an abstract operation, it would work, but it's not. So I'm going to have to call get symbol. If this had come in as an abstract operation, I can access the private members, even though it's on another object. So the private only extends to other classes. Since these are both operation classes, it can access each other's private things. So because you and I are both humans, you can find out my bank PIN. Because even though my bank PIN is a private variable, you're also a human, so you can access it directly. Just the way life works. Fortunately, life doesn't actually work that way. So now we've got plus then minus, which we've had all along, but yeah, we've got plus and minus. If I want to make it minus then plus, I could change this by multiplying minus 1, and now it should, minus 1, now it should be minus plus, hopefully. It's not, because I did this with string. Well, I've just shown you a whole bunch of stuff that I didn't need to show you, but hey, it's cool. You've got to see ways to do things. So the problem is that my map, it's the key, not the value. So it's sorting by the plus and the minus, which are strings. So I can't change the way strings compare to method works. But we learned a lot about polymorphism, or practiced a lot more with polymorphism and stuff like that. So you got to see some more of that. So that's good. But I can't change the way the sort order works for plus and minus. I want to reverse the sort order. Fortunately, there is a way to do that. So in the tree map, there's a constructor that takes a comparator. So I can make a new, actually I can't show you that yet. I will have to show you that in a separate video, because we haven't covered this particular thing yet. So I'm going to do it a different way, but I will revisit this with that other video. So I want to do a So there's a thing called a comparator. And it's unhappy because I haven't provided the methods. And I could provide all of these, but we're only going to provide the one that we have to. You might say, wait a second, that's an interface. I'm supposed to provide all the methods in an interface. This is those default methods, which I'm not talking about. I don't like them. But that, if you're wondering why I didn't have to extend all, why I implemented it, but I didn't have to implement all the methods, that's why. So right now I have O1 dot compare to O2. Right, so we're comparing this string to that string. And I can say that I want to pass in a new reverse string comparator. That means whenever it's going to do the comparison that hash map, the tree map does to print things out or to return things in a sorted order, it'll now do minus plus, assuming I implemented this code correctly, which I probably did not. So it did plus minus still. So I have two ways to fix this. I'm going to try the cheap way. I'm just going to do O2 and O1. And now it sorts in reverse. So there's our reverse sort. The other way I could have done it was to do that times minus 1 thing. Right? So if I do this times minus 1, we should be returned back to our original sort order, which is plus than minus. Right? So all I was doing is just, and I 100% of the time get my comparators the wrong way around to begin with, and it just means I have to switch what I'm sorting on. So that is a useful thing. Comparators allow you to sort things in their non-natural order. Right? The natural order is whatever the compare to method returns. That's the natural order. If you want to provide a completely different sort, we can do it this way. So think about a student class. I could sort by student ID. I could sort by last name. I could sort by first name. I could sort by GPA. I could sort by whatever I want. So I can provide one sort that's the true sort, the natural sort, based on student number, and then I could provide other comparators to do the sorting in different ways if I wanted to. We're going to come back and see some other collection type things because the next videos all deal with more collection things. And that's it.